Every morning it is there. Its light, traveling for 8 minutes across 93 million miles of void, touches the eastern horizon and pulls the world from darkness. It has warmed the skin of every human being who has ever lived. It has dictated the rhythm of our days, the turn of our seasons, the very flow of life on our planet. For 10,000 generations of human history, the sun has been the one absolute, unwavering constant in our sky. It is the great golden guarantor of our existence, a symbol of permanence in a world of change. We build our calendars by its journey, and our lives by its light. It feels eternal, but this is a beautiful, profound, and deeply human illusion. In the grand cold ledger of the cosmos, there are no constants. Everything is in flux. Every mountain will erode, every ocean will shift, and every star, even our own, has a birth, a life, and a death, written in the nuclear fires at its heart. The sun is not a static, eternal lamp in the sky. It is a dynamic, evolving, and ultimately temporary phenomenon. It is a story, and we are living in a single, blissful paragraph in its long and dramatic narrative. To understand the sun's true nature, we must first learn to see it not as a symbol, but as an object, a physical body, a star. It is a nearly perfect sphere of incandescent plasma, so massive that it contains 99.8% of all the matter in our solar system. Within its core, conditions are so extreme, with temperatures exceeding 15 million degrees Celsius and pressures billions of times greater than the atmosphere at Earth's surface, that a miraculous process occurs. Atoms of hydrogen, the simplest and most abundant element in the universe, are slammed together with such force that they overcome their natural repulsion and fuse, creating atoms of helium. This process, nuclear fusion, is the sun's engine. It is a controlled stellar-scale explosion where every second 600 million tons of hydrogen are converted into 596 million tons of helium. The missing 4 million tons of mass are transformed directly into pure energy. As described by Einstein's famous equation, chaos E2, this energy, born in the unimaginable forge of the core, takes a long, tortuous journey outward. It is absorbed and re-emitted countless times over a 100,000-year journey, until finally it reaches the surface and radiates out into space as the sunlight that defines our world. This balance, this perfect stalemate between two titanic forces, is the reason for our sun's present stability. For billions of years, the outward pressure generated by this relentless fusion has been in perfect equilibrium with the inward crush of the sun's own immense gravity, which is constantly trying to collapse the star upon itself. This balance is the reason the sun has shone so steadily for so long, providing the stable environment in which life on Earth could arise and evolve. Yet this stability is deceptive. It is the stability of a reservoir slowly being drained. The sun is not burning in the way a log in a fireplace burns. It is consuming its fuel. With every second that passes, with every photon that journeys to Earth, the sun is irrevocably changing. The hydrogen in its core is finite. It is being transformed into the inert helium ash that settles in the star's heart. The sun is, in a very real sense, writing its own death sentence with the very light that gives us life. The timeline is so vast it mocks human comprehension. The sun has been fusing hydrogen for 4.5 billion years, and it has enough fuel to continue for another 5 billion. We are, by this cosmic clock, in the sun's comfortable, stable middle age, but the processes that will lead to its end are already encoded in its structure, ticking away with the same inevitability as a falling object drawn by gravity. The constant sun of our human experience is a fleeting moment in an epic saga of transformation. The star we depend on is on a journey, and the comfortable chapter we know will eventually turn. The light we take for granted is the product of a battle that cannot last forever. To know the sun is to know that even the most permanent fixtures in our lives are merely scenes in a much greater story, a story that will continue long after our own has faded. And that story is one of both magnificent creation and inevitable dissolution.
The sun in its prime is a masterpiece of cosmic equilibrium. It is neither growing nor shrinking. It is not flickering wildly in brightness. For billions of years, it has maintained a nearly perfect constancy, a stability that has allowed life to take root and flourish on our world. This state of grace is not a passive condition. It is the result of a violent, perpetual, and exquisitely balanced war being waged within its heart. The sun is a battlefield, and the two opposing forces are the most fundamental in the cosmos: gravity and the nuclear force. Gravity is the great unifier, the relentless architect of structure in the universe. Its sole desire is to pull things together. From the moment the first wisp of the primordial solar nebula began to collapse, gravity has been trying to crush the sun into the smallest, densest object possible. It acts incessantly, pulling every atom of solar plasma toward the star's center with unimaginable force. Without a countervailing power, gravity would compress the sun into a smoldering, Earth-sized cinder in a matter of hours. It is the ultimate expression of collapse. The force standing in gravity's way is born from the very collapse gravity itself instigated. As the young sun contracted under gravity's pull, the pressure and temperature at its core skyrocketed. When the core temperature reached a critical threshold of about 15 million degrees Celsius, a new and spectacular process ignited: nuclear fusion. In this stellar alchemy, the immense pressure and heat force the nuclei of hydrogen atoms, which are positively charged and naturally repel each other, to slam together with such violence that they overcome their electromagnetic aversion. They fuse, creating a new, heavier element: helium. This act of creation releases a staggering amount of energy, as predicted by Einstein's EMMC2. The tiny amount of mass lost in the reaction is converted directly into a titanic burst of pure energy. This energy manifests as intense radiation, gamma rays, and an immense outward pressure that pushes relentlessly against the surrounding layers of the star. This is the sun's counterattack, a thermonuclear rebellion against gravitational collapse. So we have our two combatants. From the center, the furious energy of fusion pushes outward, trying to blow the star apart. From all directions, the crushing weight of the sun's own mass, governed by gravity, pulls inward, trying to implode it. For most of a star's life, these two titanic forces are locked in a perfect, spectacular stalemate. This state of balance is known as hydrostatic equilibrium, and it defines the sun's current phase of life, what astronomers call the main sequence. A star on the main sequence is a model of efficiency. The rate of fusion in its core is perfectly tuned to the weight of the overlying layers. If for a moment fusion were to surge too strongly, the core would expand slightly. This expansion would cause it to cool and become less dense, which in turn would slow the rate of fusion back down. Conversely, if fusion were to wane, gravity would gain the upper hand, compressing the core. This compression would heat it up and increase its density, causing the fusion rate to spike once more, restoring the balance. It is a self-regulating thermostat of cosmic proportions. This delicate dance is the reason for the sun's steady size and luminosity. The energy produced by fusion at the core works its way outward through a slow, random walk, being absorbed and re-emitted by atoms over a journey that can take 100,000 years. By the time this energy finally reaches the surface and escapes into space as the sunlight we know, it has been perfectly calibrated by the equilibrium at the core. The gentle warmth we feel on a summer afternoon is the direct echo of a million-year-old battle, fought to a standstill in the heart of our star. This balance, however, is temporary. It is entirely dependent on the presence of hydrogen fuel in the core. The sun is not a closed system. It is a machine consuming its primary fuel source. The very process that sustains it is also transforming it. With every second, 600 million tons of hydrogen are converted into helium, building up a core of inert ash that cannot yet fuse under the present conditions. The sun is a clock, and the gradual accumulation of helium at its center is the slow, inexorable ticking of that clock. The main sequence is not a permanent state, but a long, stable chapter in a much longer and more dramatic story. The balance will not hold forever. The day will come when the hydrogen in the core is exhausted, and when it does, the truce will be broken and gravity will begin to win the war.
We often speak of the sun as burning, a word that conjures images of a celestial campfire, a great log slowly turning to embers. This is a comforting, intuitive, and completely wrong picture. The sun is not on fire. Fire is a chemical reaction, a rapid rearrangement of atoms and electrons that releases energy stored in molecular bonds. The energy it produces is a faint whisper compared to the roaring symphony of a star. The sun's power comes from something far more profound and fundamental. It is a nuclear furnace. and the process that fuels it is nuclear fusion. This distinction is not just academic. It is the key to understanding the sun's life, its stability, and its ultimate fate. At the heart of this process is a battle against a powerful force of repulsion. Atomic nuclei are all positively charged, and, as the old saying goes, like charges repel. To get two hydrogen nuclei single protons, close enough to fuse, you must overcome this fierce electromagnetic repulsion, known as the Coulomb barrier. This requires unimaginable conditions, temperatures high enough that particles are moving at tremendous speeds, and pressures so immense that these particles are packed together, with a density and frequency that makes collision inevitable. The core of the sun provides this extreme environment. Here, at 15 million degrees Celsius, hydrogen nuclei are zipping about with such ferocious energy that they can slam directly into one another, overcoming their mutual aversion and allowing the strong nuclear force, the glue that holds atomic nuclei together, to snap into action and bind them. The specific chain of events is called the proton-proton chain. It begins when two protons fuse, creating a nucleus of heavy hydrogen. This is a fragile, temporary union. Most such pairings immediately break apart, but occasionally, this deuteron will quickly capture another proton, forming a light isotope of helium. Finally, when two of these light helium nuclei collide, they can fuse into a single, stable nucleus of normal helium, comprised of two protons and two neutrons. This final step also releases two leftover protons, which are thrown back into the seething plasma to fuel further reactions. The magic, the source of all the sun's power, is in the numbers. If you were to take the mass of 4 individual hydrogen nuclei and compare it to the mass of the single helium nucleus they create, you would find a discrepancy. The helium nucleus is slightly lighter. A tiny fraction of the original mass, about 0.7%, has simply vanished. But according to Einstein's revolutionary insight, E equals mc, mass and energy are two sides of the same coin. That missing mass has not disappeared. It has been converted into a colossal amount of pure energy. It is this energy, released as high-energy gamma-ray photons and the kinetic energy of particles, that floods the solar core, creating the outward pressure that holds the star up against its own weight. This is the engine that has run for 4.6 billion years, and it is an engine that is fundamentally changing its own workshop. The sun is not simply converting hydrogen into energy, it is systematically transforming the elemental composition of its core. The hydrogen fuel is being consumed, and in its place, the ash of the reaction is accumulating, a growing core of inert helium. This helium ash is a dead weight. It cannot fuse under the current temperatures and pressures in the core. It simply sits there, compacting under the force of gravity. This gradual transformation is the broken fuel gauge. A car's fuel gauge tells you how much gasoline remains, and when it nears empty, the engine sputters and dies. The sun's fusion engine is far more complex. It doesn't simply run out of fuel. Instead, the very nature of the fuel depot itself is being altered. The core is becoming a different place, slowly filling up with a substance that, for now, is useless to the fusion process. The balance of power is shifting, imperceptibly from our human timescale, but inexorably from a cosmic one. The sun is a clock. In the steady accumulation of helium at its center is the ticking of its hands. Every second, 600 million tons of hydrogen are forged into helium. This seems an astronomical figure, and it is, but the sun is an astronomical object. It began its life as a sphere of roughly 70% hydrogen. After nearly 5 billion years, it has consumed less than half of the hydrogen in its core. It still has a 5 billion year reservoir left, but the process is unstoppable. With every fusion reaction, with every flash of gamma light, the core becomes a little richer in helium and a little poorer in the hydrogen that sustains the delicate balance. The sun is living on borrowed time, a loan taken out at its birth, and it is spending its principal with every second that passes. The fire of fusion is not eternal. It is a brilliant, finite chapter in the life of a star, and its final embers are already being prepared in the heart of the flame.
We have established the sun's magnificent balance and the nuclear engine that sustains it. Now, we must confront the timeline. The sun is 4.6 billion years old. It has been shining with a steady, life-giving light for a period of time so vast it defies human comprehension. In that time, Earth has cooled, oceans have formed, and life has arisen from single-celled organisms to a complex biosphere that now contemplates the star that gave it birth. And yet for all this, the sun is not even at the midpoint of its main sequence life. It has approximately 5 billion years of hydrogen fuel remaining in its core. This number, 5 billion years, is so colossal as to be meaningless to our mortal minds. It is a number that offers a false comfort, a sense of such distant security that we can dismiss it as irrelevant to our world. 5 billion years from now, the continents will have been remade countless times by plate tectonics. The human species, if it still exists, will be unrecognizable, or more likely, will be long gone, replaced by other forms of life, or leaving a silent planet in its wake. It feels like forever. But in the life of a star, the final acts begin long before the last line of fuel is crossed. The end is not a sudden event. It is a slow creeping process, and its first subtle symptoms will manifest not in 5 billion years, but surprisingly soon. To understand this, we must think of the sun not as a simple container of hydrogen, but as a dynamic evolving structure. The core is not a perfectly mixed reactor. The fusion process is concentrated in the very center, where temperatures and pressures are highest. As the sun ages, the core gradually becomes richer in helium, the inert ash of hydrogen fusion. This helium core is denser and heavier than the hydrogen it replaces. To support this increasing weight, the core must respond. It contracts slightly, becoming even hotter and denser. This intensification of the core's conditions has a direct and paradoxical consequence. It makes the remaining hydrogen in the core fuse at a faster rate. This is the first tick of the clock, a slow but steady increase in the sun's luminosity. Since its birth, the sun's brightness has increased by about 30%. It will continue to grow brighter, roughly 1% every 100 million years. This is an imperceptible change on a human or even a geological timescale, but it is relentless. A 1% increase in brightness translates to a significant rise in the energy Earth receives. In about 600 million years, the increased solar energy will likely disrupt the carbonate-silicate cycle, a crucial geological thermostat that regulates Earth's climate. This could lead to a decrease in atmospheric carbon dioxide, which plants need for photosynthesis, potentially causing a mass die-off of plant life and a collapse of the oxygen cycle. Long before the core's hydrogen is exhausted, Earth will have become uninhabitable for most complex life. The oceans will begin to evaporate at an accelerated rate, and the water vapor, a potent greenhouse gas, will trap even more heat, potentially triggering a runaway greenhouse effect that could turn Earth into a scorched, Venus-like world. This apocalypse for Earth's biosphere will occur when the sun is still a stable, main-sequence star, still dutifully fusing hydrogen in its core. It is a reminder that a star's life and its suitability for hosting life on surrounding planets are not one and the same. The ticking clock, therefore, has two separate timers. One is the timer for the end of Earth's habitability, set for a mere few 100 million to 1 billion years from now. The other is the timer for the sun's own dramatic transformation, which begins in earnest in about 5 billion years. The first is a slow-boil crisis for any biosphere, driven by the star's gradual brightening. The second is a stellar midlife crisis, a fundamental change in the sun's very structure. So, when we speak of the sun's 5 billion-year fuel gauge, we are speaking of the duration of its current stable phase. But the consequences of its aging begin to be felt on a much shorter time scale. The sun is not a static backdrop. It is a character in Earth's story, and its slow evolution is already writing the final chapters for life on our planet. The clock is not counting down to the sun's death, but to the end of the conditions that have allowed us to exist. The comfortable golden star we see today is, from a deep time perspective, already changing, already brightening, already setting in motion the processes that will one day render its third planet a barren rock. The silence of space is not just an absence of sound. It is the patient, inexorable ticking of a cosmic clock, counting down the seconds of a celestial summer that will not last.
The most insidious threat to our planet's future is not a cataclysm from the depths of space, but a slow, silent transformation of the star we hold so dear. The sun, the very source of all life and warmth, is undergoing a change so gradual that it is imperceptible across millennia, yet so relentless that its consequences are absolute. It is growing brighter. This is not a theory or a distant possibility. It is a measurable, ongoing process dictated by the immutable laws of stellar physics. The stability of our climate, the very existence of our oceans, and the future of all complex life on Earth are under a sentence passed by the slow brightening of our sun. This luminosity creep is a direct and unavoidable consequence of the sun's fusion engine. As the sun fuses hydrogen into helium in its core, the number of particles in the core decreases. 4 hydrogen nuclei are fused into 1 helium nucleus. Fewer particles mean less pressure to support the outer layers of the star. In response, gravity gains a slight temporary advantage, causing the core to contract and heat up. This increased temperature and density causes the remaining hydrogen to fuse at a more furious pace, releasing more energy. This increased energy output pushes the outer layers back out. restoring equilibrium but at a higher overall luminosity. The sun is running hotter and brighter to maintain its balance against the slow internal accumulation of helium ash. It is a positive feedback loop of the most profound kind. The star must consume its fuel faster to keep from collapsing under the weight of its own waste. The numbers are small, but their implications are vast. Since it ignited 4.6 billion years ago, the sun's luminosity has increased by approximately 30%. It continues to brighten by about 1% every 100 million years. 1% seems trivial, a rounding error in the grand scheme of things. But for a planet whose climate system is a delicate balance of incoming solar radiation and outgoing heat, a 1% increase is a monumental shift. It is the climatic equivalent of a steadily rising fever. The first and most critical victim of this increasing solar output will be Earth's carbon cycle, the planet's natural thermostat. This cycle, which involves the weathering of silicate rocks and the regulation of atmospheric carbon dioxide, works to stabilize global temperatures over geological timescales. As temperatures rise due to increased sunlight, silicate weathering accelerates, pulling more CO2 out of the atmosphere. This reduces the greenhouse effect and cools the planet, counteracting the warming. It is a brilliant self-regulating system that has kept Earth habitable for billions of years. However, this system has its limits. As the sun continues to brighten, the weathering process will have to work harder and harder to remove CO2. In roughly 600 million years, the concentration of carbon dioxide in the atmosphere will have fallen so low that C3 plants, which comprise the vast majority of plant species including trees and food crops, will be unable to perform photosynthesis. This will trigger a catastrophic collapse of the planetary biosphere. The great forests will wither and die, the oxygen they produce will plummet, and the complex animal life that depends on that oxygen will suffocate. The Earth will experience a great degreening, a slow, silent return to a microbial world. The next and perhaps final stage for Earth is the runaway greenhouse effect. As the sun's luminosity continues to climb, the increased solar energy will cause the oceans to evaporate at a greater rate. Water vapor is itself a powerful greenhouse gas. More water vapor in the atmosphere traps more heat, which in turn causes more evaporation. This positive feedback loop, once initiated, becomes unstoppable. The entire ocean will eventually be boiled away, creating a thick, soupy atmosphere of steam. Ultraviolet light from the sun will then break apart the water molecules in the upper atmosphere, and the lightweight hydrogen will escape into space forever. The Earth will be left a dry, scorched, and Venus-like world, its surface temperatures hot enough to melt lead, all under the glare of a sun that looks, to a casual observer, no different than it does today. This is the true nature of the luminosity creep. It is a slow-motion apocalypse driven not by impact or explosion, but by the steady, patient ticking of stellar evolution. The star that gave us life will in time take it away. The comfortable golden sun of our afternoon sky is in reality a slowly intensifying furnace. Its gentle warmth is a temporary mercy in a cosmic timeline that points toward an inevitable fiery end. The first symptom of the sun's mortality is not a dramatic flicker, but this quiet, relentless brightening, a luminous countdown to the end of the world it made possible.
For billions of years, the heart of the sun has been a place of unimaginable violence and perfect balance. A continuous, controlled thermonuclear explosion has raged, its outward push perfectly countering the star's own immense weight. But this state of grace, this hydrostatic equilibrium, is a temporary truce. It is entirely dependent on a finite resource, the hydrogen fuel in the core. And after 5 billion years of steady burning, that fuel finally runs out. This is the moment the core dies. It is not the end of the sun, but it is the end of the sun as we know it. It is the single most dramatic turning point in its life cycle. The process begins subtly. The core has been gradually transforming, becoming richer and richer in the helium ash of hydrogen fusion. This helium is inert. Under the core's current conditions of temperature and pressure, it cannot fuse. It is a dead weight, compacting at the very center of the star. The fusion of hydrogen does not stop everywhere at once. It retreats, forced out of the helium-clogged center and into a thin, shell-like region surrounding the now inert core. In this shell, the last reserves of hydrogen undergo fusion with a new and desperate intensity. For a brief time, this shell burning masks the crisis. It even produces more energy than the core did in its final days. But this is a fever, not a renewal. The balance of the star maintained for so long is now irrevocably shattered. The fundamental engine of the main sequence has failed. With no fusion in the core to generate outward pressure, there is nothing left to fight gravity. For the first time in 5 billion years, gravity wins outright. Unleashed and unopposed, it begins to crush the core with terrifying force. What follows is a violent, transformative collapse. The core of the sun, a sphere of hot, inert helium, is compressed. As it is squeezed, a fundamental principle of physics takes over. Squeezing a gas heats it up. The core temperature, already at 15 million degrees, begins to skyrocket. This is not the gentle, stable heat of fusion, but the fierce, compressive heat of gravitational contraction. This collapse is not a slow sagging. It is rapid and dramatic. In a relatively short time by stellar standards, the core is compressed to a fraction of its previous size, becoming incredibly dense and hot. The particles within it are forced into a bizarre and extreme state of matter known as degeneracy. In a degenerate gas, the rules change. The pressure becomes less dependent on temperature and more on the sheer brute force density of the particles, which are now packed together like sardines. The core becomes a degenerate helium core, a hot, dense, and fantastically compact object that behaves more like a solid than a gas. Meanwhile, the energy released by the gravitational collapse of the core, combined with the furious output from the hydrogen-burning shell, has a catastrophic effect on the rest of the star. This massive influx of extra energy does something simple and dramatic. It forces the star to swell. The outer layers of the sun, subjected to this tremendous new pressure from below, have no choice but to expand. They balloon outward at an astonishing rate. The sun is no longer the stable main sequence star we know. It is entering its next and most destructive phase. It is becoming a red giant. The death of the core, therefore, is the trigger for the death of the inner solar system. The quiet, stable star that nurtured Earth is gone, replaced by a bloated, unstable behemoth. The delicate balance is broken, and gravity's temporary victory in the core has unleashed forces that will ultimately lead to the star's spectacular dissolution. The sun's long, peaceful summer is over, and a violent and magnificent autumn has begun.
The silence in the core is deafening. For 5 billion years, this region had been the roaring heart of a star, a continuous thunderclap of nuclear fusion whose energy held the entire sun aloft. Now, that thunder has ceased. The last embers of hydrogen have been fused in a desperate shell around the core's edge, and the central forge has gone dark. In that sudden quiet, a force that had been held in check for eons stirs. It is gravity, the great architect of the cosmos. And its patient, relentless counterattack is about to begin, with the outward push of fusion extinguished. The delicate stalemate of hydrostatic equilibrium is shattered. There is nothing left to resist. Gravity, which had been perfectly balanced, now operates unopposed. Its objective is simple and brutal: to pull every atom inward, to compress the star into the smallest, densest possible configuration. The core of the sun, a sphere of hot, inert helium, becomes the primary battleground. It is a battlefield where gravity faces no opposition, and the consequences are both violent and transformative. The collapse is not a gentle settling. It is a rapid, dramatic implosion. The core, once a vast region spanning a significant fraction of the sun's interior, is ruthlessly compressed by the immense weight of the overlying layers. As it contracts, a fundamental law of physics takes command: the conservation of energy. The gravitational potential energy lost in the collapse must be converted into another form. It becomes heat, an astonishing amount of heat. The temperature of the core, already at 15 million degrees Celsius, begins to skyrocket, soaring to 100 million degrees and beyond. This is not the stable, self-regulating heat of fusion. It is the fierce, frantic heat of sheer gravitational violence. This heating occurs because the collapsing gas is being squeezed. Imagine a bicycle pump. As you compress the air inside, the pump barrel grows hot. The same principle operates on a stellar scale, but with forces beyond human comprehension. Every atom in the core is being slammed into its neighbors with tremendous force. And this frenetic motion is what we measure as a dramatic rise in temperature, as the core collapses and heats. Another profound change occurs. It becomes degenerate. This is a bizarre state of matter that does not exist in our everyday experience. In a normal gas, if you heat it, the particles move faster and the pressure increases. In a degenerate gas, the particles are forced so close together that they cannot be compressed further without violating the fundamental quantum rules that govern their behavior. The pressure in a degenerate gas comes not from the particles' thermal motion, but from this simple, unyielding fact of quantum exclusion. The particles literally have no more room to move. The core becomes a superdense, Earth-sized sphere of degenerate helium, a hot, inert crystal forming at the heart of the dying star. This gravitational counterattack, however, does not only affect the core. The energy released by the core's collapse, the tremendous gravitational energy converted into heat, must go somewhere. It floods outward, pouring into the surrounding layers of the star. This massive influx of energy has a catastrophic and spectacular effect. It acts like a titanic piston, violently shoving the sun's outer layers outward. The star begins to inflate at an astonishing rate. The relatively stable, main sequence sun is being torn apart from the inside. The outer layers, now unmoored from the stable core and blasted by this wave of energy, balloon outward. They are cooler, but they expand to such an enormous volume that the total light output of the star increases dramatically. The sun is no longer the golden, stable sphere we know. It is on its way to becoming a red giant. Gravity's victory in the core, therefore, is a Pyrrhic one. In its triumph, it has unleashed forces that will ultimately lead to the star's magnificent dissolution. The crushing of the core is not the end of the story, but the dramatic beginning of its final, most spectacular acts. The quiet, ordered star is gone, and in its place, a chaotic, evolving giant is being born. The counterattack has broken the old order, and from its ruins, a new and terrifying phase of stellar life will emerge.
The core is lost. A sphere of inert, degenerate helium, it is no longer a source of energy but a gravitational anchor, collapsing in on itself under its own weight. Yet, just beyond this dying ember, a final, desperate drama is unfolding. The core's catastrophic collapse is not an isolated event. Its violent repercussions are about to trigger a last, furious stand from the only fuel the sun has ever known, hydrogen. Surrounding the shrinking core lies a pristine shell of hydrogen that has, until now, been too cool and diffuse to fuse. It has waited for billions of years in the shadow of the core's brilliance. But as the core contracts, it does more than just heat itself. It acts like a gravitational furnace, radiating an intense and rising heat into this surrounding shell. The temperature and pressure at the base of this hydrogen shell begin to climb, reaching the critical threshold for fusion. A new fire is lit, but this one is different. It is not the stable, self-regulating blaze of the main sequence. It is a runaway inferno. This is shell hydrogen burning, and it is a far more violent and unstable process than core fusion. The shell is a thin, dense, and incredibly hot region, sandwiched between the expanding outer layers of the star and the contracting inner core. It is under tremendous pressure from all sides. Here hydrogen fusion proceeds at a frantic, profligate rate, consuming fuel with a desperate urgency that the stable sun of old never knew. This shell becomes a monstrously powerful engine, generating far more energy than the core ever did in its final billion years. This newfound and ferocious energy source has a single dramatic outlet. It must push outward. There is no longer a stable core to absorb and regulate this output. The titanic radiation pressure generated in the hydrogen shell slams into the overlying layers of the star with the force of a continuous explosion. This energy does not gently heat the star. It violently inflates it. The sun's outer envelope, which for so long was held in a delicate balance, is now subjected to an internal pressure it cannot withstand. It is forced to expand, not as a gentle swelling, but as a rapid and massive ballooning. The star's radius begins to increase by tens of millions of miles. As these layers expand, they do what any gas does when it expands: they cool. The vibrant, white-hot surface of the main sequence sun shifts down the color spectrum, first to yellow, then to orange, and finally to a deep, ominous red. The sun is becoming a red giant, This transformation is driven entirely by the last stand of hydrogen in the shell. The fusion there is so intense and so profligate that it is in effect tearing the star apart from the inside. The delicate balance that defined the Sun's long prime has been replaced by a destructive feedback loop. The shell burning forces the star to expand and cool, but the expansion itself changes the internal structure, which in turn affects the rate of fusion in the shell. The star is no longer in equilibrium. It is a chaotic, evolving system, lurching toward a new temporary stability as a giant. This is the ultimate paradox of the Sun's demise. Its death throes are not marked by dimming, but by a brilliant, bloated luminescence. The last furious burning of its primary fuel is the very thing that dismantles the star we know. The hydrogen in its final act does not go quietly. It unleashes a power so great that it fundamentally reshapes the solar system, ensuring that its final legacy will be one of both creation and destruction. The last stand of hydrogen is not a whimper, but a roar that echoes through the star's expanding form, a final magnificent rebellion before the final silent sleep.
The stable golden star of Earth's sky is gone. In its place, a transformation of terrifying majesty is underway. The Sun is no longer merely a star. It has become a force of cosmic renovation, and its first act is one of immense, deliberate inflation. This is not an explosion, but a great, slow unfurling, a ballooning of the stellar atmosphere on a scale that defies human comprehension. The Sun is being reborn as a red giant. The process begins gradually, with the Sun entering its subgiant phase. It is a period of unsettling change. Over millions of years, the familiar disk in our sky begins to swell. It grows from its current size to twice its diameter, then 5 times, then 10. Its color, a result of its expanding and cooling surface, shifts from fierce white-yellow to a softer, deeper gold, and then to a distinct, luminous orange. During this time, from the perspective of any surviving life on Earth, the Sun would be a constant, unsettling presence, a great orange eye that grows larger with each passing century, its light becoming more diffuse, its heat more pervasive, but the subgiant phase is merely a prelude. The true metamorphosis occurs when the Sun achieves full red giant status. The internal pressures from the shell hydrogen burning become overwhelming, and the star's outer layers surrender to the immense forces from within. The inflation accelerates into something truly monstrous. The Sun's radius expands not by factors of 10, but by factors of 100. Its outer atmosphere will eventually reach a diameter of over 100 million miles, swallowing the orbits of Mercury and Venus whole, and stretching out to touch the very orbit of Earth itself. From the perspective of our doomed world, the sky becomes a vision of apocalyptic beauty. The red giant Sun does not rise. It unfolds. It occupies a vast, searing quadrant of the heavens, a shimmering crimson ocean of plasma. There is no day and night as we know it. There is only a perpetual twilight glow as the entire sky is illuminated by the reflected light from the star's colossal, ruddy disk. Its surface, no longer a defined, brilliant boundary, becomes a turbulent, roiling cauldron of convection cells larger than continents, with stellar prominences looping millions of miles into space, arcs of fire that could easily engulf worlds. The serene, constant star of human history is replaced by a dynamic, chaotic, and terrifyingly intimate celestial body. The color is a deep, blood red or a brilliant copper, not from a lack of energy, but from the physics of a cooling surface. The same immense energy output is now spread across a surface area thousands of times greater than before. Each square inch of the Sun's new, vast surface is therefore cooler, and a cooler object radiates its light at longer, redder wavelengths. The total luminosity, however, is staggering, thousands of times brighter than the Sun is today. The gentle warmth that once nurtured life is replaced by a brutal, radiant heat that can melt rock and boil oceans. This is the birth of the red giant. It is a star that has traded its compact, efficient form for a vast, bloated, and spectacularly luminous one. It is a phase defined by extremes: immense size coupled with a relatively cool surface, tremendous luminosity born from a final, desperate burning of fuel in a thin, frantic shell. The stable heart of the main sequence star has been replaced by a degenerate core and a furious, unstable fusion furnace surrounding it. The red giant is born from the ashes of the old Sun's balance, a magnificent and destructive phoenix whose growth will redefine the solar system and spell the end for the inner worlds, including our own.
The birth of the red giant is not a solitary event. It is an act of cosmic consumption, a slow, inexorable expansion that will systematically dismantle the inner solar system. This is not a story of a single cataclysm, but a chronological unraveling. A planetary apocalypse played out over millions of years, where each world meets its end, not with a bang, but with a slow, terrifying immersion. The first to die is Mercury. For centuries, the swollen orange sun has been growing in its sky, its tides stretching and cracking the tiny planet's crust. But the end comes not from gravity, but from light. As the sun's bloated limb finally touches Mercury's orbit, the planet plunges into a sea of incandescent gas. There is no impact, no dramatic collision. The solid rock of Mercury, its craters and cliffs, simply sublimes, transforming directly from solid to vapor under the intense heat. In a matter of days, the entire world is disassembled, its atoms added to the churning outer atmosphere of the star it once orbited. Mercury ceases to be a planet and becomes a constituent of the solar atmosphere, a ghost of iron and silicate dusted into a stellar wind. Next is Venus. For a longer time, it had endured a mounting hell. Its thick global cloud deck, once a reflective shield, became a suffocating blanket, trapping the sun's increasing heat. The surface temperature, already capable of melting lead, climbed to levels that turned rock into a sluggish, glowing lava. The planet became a global magma ocean, its features melting away into a uniform, incandescent hellscape. When the sun's outer atmosphere finally envelops it, the end is both swift and strangely gentle. The superheated carbon dioxide and sulfuric acid clouds simply dissipate, boiling away into the tenuous but immense corona. The molten surface, now exposed directly to the near vacuum of the star's upper layers, flashes into a vapor of metal and rock. The morning star, a beacon of human skies for millennia, is erased. Throughout this time, from the surface of Earth, the view is one of mounting, inescapable dread. The sun no longer resembles the familiar disk of legend. It is a vast, shimmering wall of fire, a copper-colored ocean that now fills a full quarter of the sky. Its motion is imperceptible, a fixed, searing tableau of slow-moving convection cells, each one larger than a dozen Earths. There is no true day or night, only a shifting intensity of a hellish red-orange glow. The sky, even at its darkest, is a deep, bloody crimson, illuminated by the reflected light from the star's colossal, incandescent atmosphere. The landscape below is a furnace. The oceans have long since boiled away, leaving vast, salt-crusted basins. The continents are plains of glowing, molten rock, their silhouettes shimmering in the heat haze that rises from the planet's crust. The very air is a toxic, superheated soup, the atmosphere itself beginning to strip away under the relentless stellar wind. The final act for Earth is not an explosion, but an immersion. The planet does not fall into the sun. The sun simply grows to meet it. As the star's photosphere, its visible surface, expands to touch Earth's orbit, our world enters the star's tenuous outer layers. The friction with this sparse but fast-moving solar material acts as a terrible brake. Earth's orbit begins to decay, and it starts a slow, spiraling plunge into deeper, denser layers of plasma. The solid ground, already molten, is now scoured away by a hurricane of stellar particles. The iron core, the last remnant of the planet's structure, is exposed to the full, unfiltered fury of the red giant. For a brief, brilliant moment, it glows like a meteor on a cosmic scale, a final, defiant ember before it, too, is vaporized and assimilated. The atoms that once formed mountains, oceans, and living things are scattered, becoming one with the star that gave them birth. The process is silent, methodical, and absolute. The stage is cleared. The inner solar system is no more.
The fate of Earth, the cradle of humanity and the only home we have ever known, hangs in the balance of two opposing stellar processes. As the sun bloats into its red giant phase, the question is not if Earth will be destroyed, but how. The drama unfolds as a cosmic tug-of-war between the sun's expanding radius and its diminishing mass, and the outcome will determine our planet's final moments. The first and most dramatic possibility is complete engulfment. In this scenario, the sun's outer atmosphere expands relentlessly. Its visible surface, the photosphere,
pushing outward until it physically reaches and then surpasses Earth's orbital path, currently 93 million miles away. The image is both majestic and horrifying. Our world would not be plummeting into the sun. The sun would simply swell to meet it. The sky, already dominated by a colossal coppery disk, would transform into a roiling, incandescent ocean. The line between planet and star would blur as Earth entered the sun's tenuous but superheated outer layers. The planet would experience immense atmospheric drag, its orbit decaying in a slow death spiral. The rock itself, already molten from millennia of intense heating, would begin to sublimate, its material stripped away atom by atom and assimilated into the stellar furnace. The iron core, the last remnant of our planet's structure, would glow brilliantly for a final moment before vaporizing. Earth would cease to be a distinct object, its essence scattered across the star that gave it birth. However, a second, more nuanced fate is possible, one dictated by a subtle but powerful stellar phenomenon: mass loss. As a red giant, the sun will develop a powerful stellar wind, far more intense than the solar breeze of today. This wind will carry away a significant portion of the sun's own mass into space. As the sun loses mass, its gravitational grip on the planets weakens. According to the laws of orbital mechanics, a planet's orbit expands as the central star's mass decreases. It is a celestial act of letting go. This sets up a race between the sun's physical growth and its gravitational retreat. Will the sun's radius expand faster than Earth's orbit can drift outward? Current models suggest it will be breathtakingly close. Some calculations indicate that the orbital expansion could, just barely, push Earth beyond the reach of the sun's photosphere. Our planet might avoid the technical definition of being swallowed, but to call this escape is a cruel misnomer. It would be a stay of execution, not a pardon. Even if Earth's orbit widens, it will have long since been rendered a sterile hellscape. The sun's luminosity will have increased thousands of times over. Long before the peak of the red giant phase, the energy-bathing Earth will be sufficient to boil away the oceans, melt the surface rock into a global magma ocean, and strip away the atmosphere. The planet will be a scorched, glowing ball of lava, its geological features melted away, its identity erased. If it avoids direct immersion, it will simply continue to orbit as a seared cinder, a blackened rock circling a monstrous star, its surface temperature far hotter than that of molten lead. In this second scenario, Earth's final sunset would have occurred billions of years earlier. The last liquid water, the last cloud, the last whisper of a breeze would be ancient history. The planet that remains would be a ghost, a mineralogical monument to a long-vanished biosphere, continuing its silent, broiling vigil in the swollen glare of its dying star. Therefore, the two possibilities for Earth's fate are merely different versions of the same oblivion. The distinction is academic, a matter of final location rather than final state. Whether our world is vaporized within the sun's atmosphere or endures as a permanent molten relic just beyond its reach, the outcome for life, for oceans, for mountains, and for any memory of a blue planet is identically absolute. The Earth we know is destined to die, not with the cold of ice, but with the fire from which it was forged. The final sunset is not a single event, but the long, slow brightening of a sky that eventually forgets the very concept of night.
The death of the inner solar system is a localized catastrophe. For the worlds beyond the asteroid belt, the sun's transformation into a red giant is not an end, but a profound and total revolution. The wave of change that vaporizes Mercury and scorches Earth does not diminish with distance. It transforms, rewriting the very definitions of worlds and shifting the potential for life to the solar system's frozen frontier. Mars, the next world in line, experiences a fate similar to, yet distinct from, Earth's. Its thin atmosphere offers no protection. As the sun swells, the feeble Martian winter gives way to a perpetual blistering summer. The polar ice caps, a mixture of water and frozen carbon dioxide, are the first to go, sublimating directly into the thickening hot atmosphere. The rusty soil bakes under a sun that now appears many times larger than it does from present-day Earth. Any subterranean water or ice is swiftly excavated by the intense heat, briefly creating transient, steamy atmospheres before being lost to space. The planet becomes a dry, scorched orb, its canyons and volcanoes standing in stark relief under the hellish red-orange glow. It avoids engulfment, but is left as a thoroughly sterilized, superheated desert. Further out, the asteroid belt is reborn in fire. For billions of years, these rocky remnants have been frozen, dark, and inert. Now, they are bathed in the intense radiance of the giant sun. Their surfaces, once hundreds of degrees below zero, are heated to temperatures high enough to glow a dull cherry red. The metal-rich asteroids may even begin to soften, their surfaces becoming semi-molten. The belt is no longer a dark, cold junkyard, but a vast, sparsely populated ring of countless tiny, incandescent embers, each one tracing its orbit in a shimmering arc through the transformed solar system. It is here, in the middle solar system, that the old order is completely overturned. The classical habitable zone, the orbital region where liquid water can exist on a planet's surface, migrates outward with the sun's increasing luminosity. It leaves the rocky inner planets behind as scorched relics and settles upon the realm of the gas giants. Jupiter and Saturn, though their massive gaseous envelopes are stirred and heated by the new energy, remain fundamentally recognizable as gas giants. Their deep atmospheres undergoing violent and spectacular changes in chemistry and storm activity. The true transformation, however, happens to their moons. The icy crusts of Europa, Ganymede, and Enceladus, once frozen solid, begin to thaw. For the first time in billions of years, liquid water exists on their surfaces, not locked under ice but as vast warm global oceans, steaming under a swollen coppery sun. The definition of a world with Earth-like conditions shifts dramatically. These moons, once considered frozen outliers, become the new centers of astronomical interest, their temporary oceans lasting for millions of years in the sustained warmth of the giant sun. But the most radical change is reserved for the ice giants, Uranus and Neptune. In our current era, they are distant, frozen giants, their blue hues a testament to methane ice and immense cold. The red giant sun rewrites their identities. As the habitable zone sweeps past them, their frigid atmospheres are injected with immense energy. The temperature soars, melting the layers of frozen methane, ammonia, and water. Their characteristic blue and green colors shift to warmer, yellower hues, perhaps a hazy beige or a muted ochre, as their chemistry is utterly altered by the heat. They become a new class of planet, warm gas giants, worlds with thick, warm, and turbulent atmospheres, unlike anything seen in the solar system's previous history. Their own icy moons, like Triton, undergo a similar thaw, potentially developing thick, transient atmospheres and surface liquids. This is the final, ironic act of the sun's death. In its final, most destructive phase, it briefly creates conditions for liquid water, the essential ingredient for life as we know it, in the very places it was once most scarce. For a fleeting few million years, the outer solar system blossoms with a warmth it has never known. It is a cosmic springtime arriving at the end of autumn, a beautiful, poignant, and ultimately temporary gift from a dying star. The solar system, in its final configuration, is almost unrecognizable, a small, scorched inner region, a glowing asteroid belt, and a warm, oceanic outer system, all orbiting a star that has sacrificed its own stability to rewrite the fates of every world it holds in its sway.
Deep within the bloated crimson heart of the red giant sun, a silent crisis is building. The core, now an Earth-sized sphere of degenerate helium, has been crushed to a density of tons per cubic inch by the immense weight of the star's outer layers. It is a bizarre state of matter, a quantum mechanical crystal, where the rules of a normal gas no longer apply. The temperature soars under the relentless pressure, climbing past 100 million degrees. Yet the helium remains inert, its nuclei still lacking the energy to overcome their mutual repulsion and fuse. This is the calm before an unimaginable storm. The degeneracy pressure supporting the core is a ticking time bomb. In a normal gas, heat creates pressure, and pressure leads to expansion and cooling, a natural thermostat. But in a degenerate gas, the pressure comes not from heat, but from the sheer brute force packing of particles. This means the core can be heated to extraordinary temperatures without being able to expand, cool down, and self-regulate. It is trapped, a pressure cooker with a locked lid and a steadily turning flame. The trigger is pulled when the temperature finally crosses the critical threshold of about 100 million degrees. In that instant, helium fusion ignites, But this is not the gentle, self-regulating ignition of hydrogen in the main sequence star. This is a thermonuclear runaway. The first few helium nuclei fuse, releasing a burst of energy. In a normal gas, this would cause expansion and slow the reaction. But here, in the degenerate core, the energy has nowhere to go. It cannot expand. The only thing it can do is heat the core even more. This is the flashpoint. The increased temperature causes the fusion rate to skyrocket, which releases more energy, which increases the temperature further, in a feedback loop of terrifying speed and power. In a matter of seconds, the entire degenerate core becomes a single, unified fusion bomb. The helium flash is not a slow burn. It is a stellar heart attack, a convulsive detonation that releases as much energy in those few seconds as the entire rest of the galaxy combined. Yet from the outside, nothing is seen. The cataclysm is entirely hidden, absorbed by the enormous, opaque envelope of the red giant. If you were observing from a safe distance, the sun would show no outward sign of this internal apocalypse. There would be no brilliant flare, no sudden brightening. The violence is entirely contained, a secret rebellion in the star's deepest vault, but its consequences are profound. The sheer instantaneous energy output of the flash is finally enough to break the core's degeneracy. The locked lid is blown off. The immense heat provides the thermal pressure needed to overcome the quantum forces that had kept the core compressed. The core violently expands, and in doing so, it finally cools. In a cosmic irony, this most violent of events leads to a new and unexpected state: stability. The helium flash marks the end of the core's degenerate state and the beginning of a new, quieter phase of fusion. The core is now a normal hot gas, fusing helium into carbon and oxygen in a stable, regulated process, much like the hydrogen fusion of its youth. For a time, the star finds a new equilibrium. It will contract from its maximum red giant size, becoming hotter and more stable, entering a phase known as the horizontal branch. The helium flash is thus a pivotal, hidden transition. It is the moment the star cheats a more immediate demise. Without it, the degenerate core would have continued to heat until it triggered a different, even more violent end. The flash is a cosmic reset button, a brief, contained paroxysm of violence that grants the star a temporary reprieve, allowing it to burn another fuel and write one last, quieter chapter before its final, inevitable decline. It is the soundless scream at the heart of a giant, a convulsion that saves the star from itself, clearing the way for the last beautiful act of its dissolution.
The helium flash is not an end, but a violent new beginning. In its aftermath, the star's core has been fundamentally reborn. No longer a degenerate quantum mechanical crystal, it has been blasted into a hot, expanding sphere of normal gas. With the pressure cooker lid blown off, a new and stable fusion process can begin. The sun, for a brief and brilliant moment, finds a second youth. It enters what astronomers call the horizontal branch phase, a period of relative stability powered by the fusion of helium into carbon and oxygen. This new chapter brings a dramatic change in the star's appearance. The furious, uncontrolled energy from the shell hydrogen burning that had forced the star to bloat into a red giant is now subdued. With a new powerful energy source ignited in the core itself, the star's structure reorganizes. It contracts significantly from its maximum red giant size. The vast crimson orb shrinks, its surface temperature rising from a deep red to a hotter yellow-white. The total luminosity remains immense, but it is now generated from a more compact and hotter object. From a distant observer's perspective, the star appears to have reversed its aging process, moving back toward the main sequence on astronomical charts. This stability, however, is built on a foundation even more precarious than the first. The fusion of helium is a far more sensitive and efficient process than hydrogen fusion. It operates at a much higher temperature and is exponentially dependent on that temperature. This makes the core a wildly sensitive engine. The slightest contraction causes a dramatic spike in the fusion rate, which leads to a rapid expansion that then cools the core and throttles the reaction back down. The star pulsates gently, finding a new but fragile balance. Furthermore, the fuel for this second youth is both scarce and quick-burning. Helium fusion is a profligate process, consuming its fuel at a tremendous rate. While the star may have spent nearly 10 billion years fusing hydrogen in its core, the helium-burning phase will last for a mere fraction of that time, perhaps only 100 million years. The star is living on borrowed time, spending its final reserves of nuclear fuel in a brilliant but brief flash of renewed energy. During this time, the star's internal structure becomes a complex, layered onion. At the very center, the core fuses helium into carbon and oxygen. This core is surrounded by a shell where the previously burned helium ash lies dormant. Beyond that, the shell of hydrogen fusion still smolders, though its role is now secondary. And enveloping it all is the vast, diffuse atmosphere of the star, which has settled into a temporary, more compact configuration. This reprieve is the calm before the final storm. The very process of this stable helium burning is creating the seeds of the star's ultimate destruction. The end product of this fusion is carbon and oxygen. Just as the hydrogen-burning phase ended with an inert core of helium ash, the helium-burning phase is producing an inert core of carbon and oxygen ash. This new core will eventually grow massive enough to become degenerate once more, setting the stage for the next and final series of convulsions. This brief, unstable reprieve is a poignant chapter in the star's life. It is a demonstration of the star's resilience, its ability to find a new equilibrium even after a catastrophic internal event. For a short while, the chaos of the red giant phase subsides, and the star shines with a steady, hot light. But it is a stability born of violence and leading to further instability. The second youth is a beautiful, transient gift, a final chance to shine brightly before the last, irreversible decline begins. The star is gathering itself, burning through its last major fuel reserve and preparing for the dramatic finale of its existence.
The brief, stable summer of helium fusion cannot last. Deep within the star's core, the helium fuel is being consumed with profligate speed, transformed into an inert ash of carbon and oxygen. Just as with hydrogen before it, the day arrives when the core's helium supply is exhausted. Fusion sputters and dies, and with its passing, the star's carefully reconstructed equilibrium shatters completely. The sun now embarks on its final frantic dance, a period of violent and rhythmic convulsions known as the thermal pulses of the asymptotic giant branch. This phase is one of sheer stellar insanity. The star's structure has become a complex and unstable onion of fusion shells. With a dead core of carbon and oxygen, a shell of helium now ignites directly above it, fusing furiously, and above that the shell of hydrogen fusion still burns. But these two furnaces are not harmonious. They are locked in a deadly resonant conflict. The cycle begins with the helium shell. It ignites and burns with a ferocious runaway intensity, much like a series of smaller, contained helium flashes. This explosive burning produces a colossal wave of energy, a thermal pulse. This energy does not gently radiate outward. It acts like a titanic piston, violently shoving the entire star's envelope outward. The star balloons once more to an even larger size than before, becoming a truly monstrous red supergiant. But this expansion has a critical consequence. It smothers the hydrogen-burning shell located further out. The sudden outward movement cools and dilutes the hydrogen shell, causing its fusion to sputter and nearly die. For a time, the star is powered almost entirely by the furious last-gasp burning of its helium shell. This state is not sustainable. The helium shell quickly consumes the available fuel in its immediate vicinity. Its fire dies down. With the powerful outward pressure from the helium shell suddenly removed, the star's immense outer layers, which had been pushed to a precarious extreme, now collapse inward under their own weight. This inward contraction is not a gentle settling. It is a violent fall, a gravitational avalanche that compresses and reheats the hydrogen shell, which had been lying dormant, reignited under this immense pressure. The hydrogen shell roars back to life with a vengeance, generating a new wave of energy that once again pushes the outer layers back out. The star begins to swell again, and the cycle is reset. The helium shell, now compressed and heated by the star's changing structure, eventually gathers enough fuel and heat to ignite again, and the entire chaotic process repeats. Each one of these thermal pulses lasts for tens of thousands of years, a frantic oscillation between two unstable states. The star is no longer a coherent entity but a battlefield, its structure rhythmically torn apart and reassembled by the warring fusion shells. With each pulse, the star loses a tremendous amount of its mass, Powerful stellar winds, fueled by the violent energy releases, strip away the star's outer layers and blow them into the surrounding void. The star is literally coming apart at the seams, vomiting its own substance into space. This is the final, desperate struggle of a star that has run out of options. Its core is dead, a degenerate cinder that can no longer fuse. Its remaining fuel burns in unstable, competing shells that tear the star apart from the inside. There is no recovery from this, no new equilibrium to be found. The thermal pulses are the death throes, the final frantic gasps of a star systematically dismantling itself. It is a spectacular and violent end, a chaotic crescendo that precedes the final, quiet silence. The star is no longer fighting for its life, but actively participating in its own dissolution, casting off its own atmosphere in great, rhythmic heaves until nothing but its bare, dead core remains.